Let's turn, though, to a fascinating story because scientists have discovered a gigantic ring-shaped structure in space which is so big it challenges our understanding of the universe.
There is a groundbreaking idea suggesting that there might be a force even greater than God, driving religious authorities completely insane. A 13-year-old genius has just challenged this idea with his gifted common sense.
The point about that is that means that there is power that is greater than God. And considering that there is an infinite number of vibrations and therefore an infinite number of realities within our dimensional space.
Now think about the Mandela Effect, where no usual rules apply. This could devastate the world order and create a new one full of chaos. What if we only need one logical answer to eliminate the existence of God? Join us as we reveal the shocking truths that religious leaders are hiding from the believers. Infinite universes, fact or fiction? As we explore this endless sea of possibilities, we must ask whether such discussions truly help us understand the universe or just blur our view of real scientific questions that require attention. While the idea of many universes and divine conflicts may offer an engaging story, it might also distract from more concrete scientific pursuits that aim to decode the universe through observable and measurable data. This situation calls for a reevaluation of our focus. Should we use our brain power to unravel hypothetical scenarios that might never be proven? Or should we concentrate on more measurable and observable aspects of science that promise clearer answers about our existence? While it's intriguing to think about the limitless potential of universes and the complexities of divine abilities, such thoughts should not pull us away from pursuing scientific questions. Such questions are more likely to give us tangible benefits and a clearer understanding of the cosmos we inhabit. Entertain the idea that there might be an infinite number of other realities and dimensions similar to ours, where different forms of what we know as the equation E equals sine mc2 exist. Sounds more like a science fiction story than serious science. The theory suggests some of these realities might have a more powerful or weaker force at play, similar to what we consider a godlike power. While this is an intriguing thought, it often feels more like wild speculation than something grounded in reality. Let's consider the popular thought experiment of trying to fit the idea of infinity into a limited space. We're taught to visualize this by drawing a line and then making smaller and smaller divisions of that line, which supposedly helps us understand infinity confined in a space. This representation, turning into a triangle shape, is meant to show infinity in a tangible form. However, it's hard not to see this as a clever visual trick rather than a rigorous scientific explanation. The notion of adding infinities together, or considering infinities of infinities like omega to the power of omega, feels more like diving into a deep sea of theoretical complexity without a clear purpose. These discussions about different sizes and types of infinity, like uncountable cardinals, a type of infinity so large that we can't even begin to count it, might excite mathematicians, but for many they seem detached from reality. This ongoing conversation about the vastness and variations of infinity often appears to be more about showing off mathematical skill than about enhancing our practical understanding of the universe. Educational resources, such as the Vsauce video titled "How to Count Past Infinity," try to make these mind-bending concepts more accessible. They provide a gateway to advanced mathematical ideas, but also highlight the gap between theoretical mathematics and everyday scientific application. The endless discussion of infinities serves as a reminder of our limitations in understanding and applying these concepts in a meaningful way in the real world. Let's break down our discussion about energy equals mass times the speed of light squared and the redefined concept of God. First, let's tackle quantum physics, where things work quite differently from our everyday world. In quantum physics, particles can be in two states at once, both positive and negative. This contrasts with the everyday world where things are more straightforward and predictable. Quantum physics introduces the idea of superposition, which might sound like a fancy way to avoid giving clear answers. According to this theory, everything exists in multiple states at once until it is observed. This leads us to an even bigger idea, the multiverse. Here it's said that there are countless parallel universes existing alongside ours. Next, let's see how tiny actions might lead to new worlds. The Mandela Effect, misremembered or multidimensional. According to this theory, every tiny action, like an electron spinning around an atom's nucleus, could potentially shift us into a new universe. It suggests that from the moment our universe began with a big bang, our timeline has been splitting into infinite versions, creating endless parallel universes. This concept is intriguing and gives scientists and thinkers a lot to discuss. However, it's important to look critically at these ideas. While it's exciting to think about infinite universes branching off with every tiny change in our universe, we should consider whether this is a bit too enthusiastic. The idea that every small atomic movement can transport us into a different reality might sound like something out of a sci-fi movie rather than a scientific discussion. So as we go deeper into the idea of an infinite number of universes stemming from every atomic event, we should balance our excitement with a critical eye. These discussions go way beyond what we can currently prove. While they're great for stimulating thought and expanding our views of what might be possible, they also show how much we still have to learn and understand about the universe. We're using complex scientific terms to describe theories that are far from being proven, often blurring the lines between real science and speculative fiction. It's fascinating to think about these possibilities, but we must also ask ourselves how these ideas fit into the observable and measurable universe. Discussions like these push the boundaries of our knowledge and understanding, and they challenge us to think about the universe in new and different ways. However, they also remind us of the limitations of our current scientific understanding and the vast unknowns that remain. We are constantly trying to make sense of the cosmos, often using theories that are as grandiose as they are untestable in current scientific practice. This theory suggests that a tiny change in an electron's mass caused by a particle accelerator could completely wipe out our universe and shift us into a nearby one. In this new universe, small differences become our accepted reality. The Mandela Effect itself revolves around shared incorrect memories, such as many people believing Nelson Mandela died at a time he did not, or recalling movie lines that are different from the actual scripts. For example, many remember a line from the movie Snow White as "Mirror, mirror on the wall," when it's really "Magic mirror on the wall." These are frequently pointed out as evidence that we've moved to another universe. Those who support this idea often use personal experiences to back up their claims, like finding strange handwriting in their own notebooks or noticing changes in well-known movie lines that seem different from what they remembered. However, it's important to view these claims with a bit of skepticism. The idea is based on the major assumption that our universe has been destroyed and replaced, but it doesn't really explain how such a massive event could happen without anyone really noticing, except for some small differences in pop culture. Moreover, explaining these ideas typically uses complex terms that sound scientific, but don't hold up to actual scientific examination. The notion that our entire universe shifted because of alignment issues with parallel universes sounds like something out of a sci-fi movie, but is hard to take seriously as scientific fact. This discussion often strays into speculation without solid proof, leading to more confusion than clarity. How can anyone prove for sure that their memories of a movie line or an event are leftovers from another universe and not just simple mistakes? The debate gets even more complicated when we consider the idea of two identical film studios producing movies with slightly different lines in what some claims are separate timelines. Is this really a sign of us moving through dimensions? Or could it just be human error or changes made by the filmmakers? While the Mandela Effect and the idea of parallel universes are fascinating topics, they often lack a clear and scientifically sound explanation for the observed phenomena. They provide interesting what-if scenarios that are fun to think about, but are probably better suited to discussions about culture and entertainment than serious scientific inquiry. This conversation often ends up with more fantastic elements than factual ones, making it a great topic for lively debate, but not one that offers concrete answers to the big questions about our universe and its many potential neighbors. Now let's explore how these ideas tie into our science. The dark side of the Large Hadron Collider. In the world of physics and theoretical discussions that sometimes feel like the wild theories of late-night college brainstorming sessions, there's a story about our universe that sounds straight out of a science fiction book. It centers around the Large Hadron Collider, a giant machine that plays around with particles like electrons. Some people think that when scientists change the mass of an electron, We accidentally moved into a different universe. They theorized that this explains why our universe didn't collapse as some had thought it might. Consider this idea. What if, in that tiny moment, we unknowingly jumped to another universe? Or more fascinatingly, what if some smart people at CERN found a tiny gap in the fabric of time and space and decided to mess with historical events, just to shake us up and make us question what's real and what's not? Could our reality be more changeable than we've always believed? It's a possibility, although it leans a bit toward conspiracy theories and tales of fantasy. Then there are bizarre stories that come from CERN. There are whispers about creatures from other dimensions and portals to other worlds that sound like they belong in a horror movie. According to these stories, such strange and wonderful actions are needed to keep our universe intact, or to connect multiple dimensions into one. As these stories spread, they become almost like a new type of mythology, believed as firmly by some as scientific facts are by others. But let's talk about fairy tales. When did we start treating them as if they were true? Yet isn't it true that there's often a bit of reality in these tales? Now back to the idea of infinity. Our universe was, is, and will always be just one of an endless number of possibilities. Somewhere out there might be a version of reality where our universe never existed or destroyed itself as soon as it appeared. Moreover, when we discuss higher levels of infinity, we dive deeper into the complexities that theoretical physics explores. Infinity isn't just a vast emptiness, but a complex collection of endless possibilities, each with its own set of circumstances and realities. Trying to understand this isn't just a matter of curiosity, it's about looking into the mechanisms that might determine everything about our past, present, and future. It's an enormous challenge, an endless exploration of potential realities that go far beyond our everyday experiences. It invites us to think bigger and bolder about the cosmos and our place within it. As daunting as it is, these infinite possibilities aren't just academic. They're a profound adventure that redefines the boundaries of human thought and imagination. Engaging with these ideas pushes the limits of our understanding and opens up a universe of endless questions and wonders. But let's be honest, are we, just regular people, really going to figure this out? Not likely, not for a while. It might even sound a bit funny to think we could. You might feel pretty sure that you understand these big ideas. But remember, these are just guesses. How can anyone really prove ideas about old universes that go on forever or different realities? This stuff is called theoretical physics for a reason. It's a bunch of theories. Nobody can claim they know everything about what's happening in the universe. You might know a little, just a tiny piece of what might be true about how things work out there in space. But that's just the beginning. We're just scratching the surface of something huge and complicated. It's like trying to explain things that might just be beyond explanation. Can we really say we've got it right? Or are we just making things more confusing? Consider this. There are universes sitting right next to each other, so close yet so far apart. Each event in each universe makes it different from its neighbor. Trying to map out this endless space is silly. You can't draw it. You can't fully imagine it. It's an endless expanse of different realities going on and on. As we try to wrap our minds around these other universes, where maybe everything is flipped upside down, we need to cool our jets a bit. We need to remember that what we understand is just a tiny part of a huge expanse. Every explanation, no matter how confident it sounds, might just be a weak attempt to make sense of the vast, complex universe around us. How much can we really claim to explain when faced with such immense and frankly overwhelming complexity? Let's examine how these thoughts challenge our view of reality. An expedition to the edges of reality. Let's think about a parallel universe, places where the normal rules we know might not apply. Perhaps everything is completely different there. What if our whole existence was meaningless or never even supposed to happen in these other universes? Imagine time running backwards, or things being just a bit off. This is based on the idea that universes could start from nuclear reactions, setting off a chain reaction that creates more and more universes, which then lead to the creation of even more. It's like a never-ending cycle of universes being born and then leading to the birth of others. Now let's talk about the Mandela Effect within this wild universe concept. It's like hints or small reminders from other universes that pop into our minds. This becomes even more interesting when we think about big scientific experiments, like those done at CERN with the Large Hadron Collider. These experiments try to figure out what our universe is made of, but they might also be touching other universes without us knowing. Imagine if by studying tiny particles, scientists accidentally affected other universes or our own universe's stability. What if when a universe ends because of these experiments, its energy isn't lost but just moves over to a universe next door? Think about it like energy moving from one room into the next through an open door. It's not about destroying energy, but just moving it somewhere else. This raises big questions about our role in the universe. Are we just leftover bits from another universe that ended? Or are we part of a continuous cycle of universes dying and being born again? And when scientists run experiments that dig into the deepest parts of the universe, are we just watching? Or are we actually changing things in ways we don't fully understand? Every time scientists turn on a machine like the Large Hadron Collider, they might not just be learning about our world, they could be changing things in other universes too. This makes us wonder about the effects of our actions, not just here on Earth, but also in the grand scale of the cosmos. Are we just observers in the universe? Or are we creators and changers of worlds beyond our own? These ideas make us rethink not only what we know about the universe, but also how everything is connected. Our actions, even just talking about these theories, might create new universes or affect distant ones. It turns the universe into a place of endless possibilities and connections, where the end of one story might just be the beginning of another somewhere else in the cosmos. When we talk about the universe being like a magical mirror, what we're really discussing are the fundamental rules of physics that define our cosmos. It's not about magic. It's about the patterns and behaviors that scientists observe and measure in space. People often use big, imaginative words to describe these concepts, but at its core, it's all about understanding the space we live in. For instance, when we hear about different planes of existence and dips, this might sound like something out of a fantasy book. In reality, these terms are just simplified ways of talking about how certain aspects of our universe behave under different conditions. It's like noticing that a stretched sheet dips differently depending on how you place objects on it. These are not gateways to other worlds, but are just variations in energy and matter that occur naturally in our universe. Then there's the mention of the Mandela Effect, which seems to be a confused reference, possibly intending to refer to something like the Mandela Effect. This effect talks about when a group of people remember something differently from how it actually occurred. While it's a fascinating psychological phenomenon, it doesn't have much to do with astrophysics or the physical properties of the universe. It's more about how human memory works and less about cosmic truths. The idea that there's another universe almost exactly like ours is a popular topic, not just in science but in science fiction. The theory of parallel universes suggests that there could be other universes similar to ours, but this is still a topic of theoretical physics and not yet proven. The use of the word almost is important because even if such universes exist, they would not be perfect copies. Small differences could lead to entirely different histories and events. It's exciting to think about these possibilities, like if there might be a planet just like Earth somewhere, or if someone like you exists in another universe. However, these are speculative ideas based on advanced mathematical theories and not on direct evidence. While it's fun to imagine these scenarios, real science is based on experiments and observable facts. Science often explores theories about multiple universes and what might exist beyond our own. But when discussing these ideas, it's crucial to stay grounded in what scientists can actually prove. Sometimes people take these theories and talk about them as if they are sure facts, leading to confusion or misleading conclusions. Let's consider how these ideas affect our memories and perceptions. The 1% difference, universes apart. Let's dive into the idea that the universe we're living in might not actually be the original one, but a part of a much bigger and more complex cosmic puzzle. This concept banks heavily on the idea of parallel universes, a topic quite popular among scientists and those who just like to think about these things from their couch. Interestingly, we're now supposed to believe that the famous line from the movie Snow White, which goes mirror, mirror on the wall, has changed to magic mirror on the wall. This shift is pointed out as evidence that we've moved to a different universe, one that's almost the same, but with some slight tweaks. This thought isn't just about a line in a movie changing. It's about the idea that small differences between universes can add up. creating a collection of worlds where tiny changes can lead to entirely different outcomes. It's a handy theory because it provides a neat explanation for when someone remembers something incorrectly. It's not a mistake, it's just a jump between universes. The argument extends to a 1% difference between our universe and another, implying that such a tiny difference is enough to keep things mostly the same, but also different enough to matter. This theory is stretched further when we consider that this 1% could change something as random as where someone decides to walk, yet everything else remains suspiciously similar. It's almost like we're expected to believe that the universe works like a scene from a sci-fi movie, bending reality to fit a particular storyline. Furthermore, the term parallel universe is used very loosely here, far removed from its serious scientific context. The idea of multiple universes is a significant and complicated topic in physics, not just a quick fix for when pop culture references to don't match up with our memories. Yet it's used here to explain why some might remember a movie line differently, simplifying a profound scientific concept to something trivial. This conversation also veers into talking about higher dimensions and the uncertainties of our reality, comparing these monumental scientific ideas to something as simple as choosing which side of the street to walk on. These analogies are not only scientifically inaccurate, they also belittle the real complex uncertainties in theories like quantum mechanics and relativity. It seems every unexplained event or minor anomaly is now an excuse to claim a shift in cosmic dimensions rather than looking for a simpler, more reasonable explanation. When we delve into big theories, it's key to keep a balance between our wild imaginations and the solid facts of science. If we start using the idea of parallel universes to explain why we forget things or notice small differences in our daily life, we're not really honoring the true spirit and excitement of scientific discoveries. It's important to stay grounded even as our thoughts take us on journeys across the stars. This way, we make sure that we're not turning deep scientific ideas into simple answers for minor puzzles in our lives. By respecting the process of scientific exploration, we deepen our understanding without trivializing the vast complexities of the universe. Meryl Streep nailed a pretty straightforward idea. Despite our differences, at the core, everyone is pretty similar. Consider someone who sees a broader spectrum of colors than the average person. This individual isn't much different from someone else who might not see those colors but possesses unique abilities. Take Ed, the mantis shrimp, for example. This sea creature isn't just known for its powerful claw. It's celebrated for its ability to perceive a vast array of colors beyond human capabilities. We only see 3 primary colors. This notion links back to the grand concept of infinite universes and the idea of infinity. While it sounds profound, it often ends up making things more perplexing than necessary. Contemplating infinity is like trying to grasp a concept that never concludes. It's fascinating, but not very practical for our daily concerns. It places our everyday problems in a vast context of endless possibilities, reminding us that ultimately, everything has an end. Returning to the topic of uncertainty, it seems to follow us like a shadow. In a funny twist, the only thing that's truly sure is that nothing is completely sure. Uncertainty hangs around us like a guest who won't leave, sneaking into every part of our lives. It's a part of our daily life that keeps making us question what we think we know. By seeing that uncertainty is always there, we start to accept it, even if a bit cynically. This acceptance shows us that our understanding of reality might just be barely touching the deeper hidden truths. This can make us feel small and unsure, pushing us to always question and rethink what we believe and see. By accepting how common uncertainty is, we open up to more possibilities. We learn to live with the unknown and the unclear, which can strangely lead to a better and deeper understanding of everything around us. It pushes us to stay curious and open, ready to change our minds when new facts or opinions come along. This way of thinking doesn't just help us understand the complex parts of life better. It also helps us adapt and stay strong when things change unexpectedly. If uncertainty is so persistent, are we ever truly in control of our lives? Like, comment, and subscribe to explore more about the challenges of our existence.